take a look at number 44 on that thing. I think it's right here. Got it. Annie volunteers for a tutoring center for her school. The table shows how much time she spends in tutoring each week for 6 weeks. Okay, what is the best? Which function best fits the data? Okay, so here's the question that we're going to have to do. Well, what I would do if I were you is I would look at the options. Okay. The options are, the first one is y is equal to negative something times x plus 220. Negative 40 times x plus 220. The second one is y is equal to negative 20 x plus some number. I don't even, 186 and 2/3. And then the next one is y is equal to, I'm going to just write it like this, and y is equal to. Now, looking at the table, here's what I would say, and keep in mind that this is a problem at the very end, so I'm assuming that this requires a little bit of thought, a little bit of thinking and understanding what's going on here. You got your table, and let me ask you this. Are the numbers changing by the same amount every time? Does that mean, am I subtracting 40, and then to get the next number I subtract 40 again, and to get the next number I subtract 40 again? No. Everyone's saying no. And you don't even need to calculate jack. You can look at that and say, I agree with that. Yeah. Okay? So it's no for that. So I would say that these two options are out. It's definitely not linear, because that's what these are. These are linear. Now, if the other options were like quadratic and cubic and that kind of stuff, those are things you got to check. But initially, right off the bat, without even doing any calculations, we can cross off linear, because we look at that and just be like, yeah, that doesn't make any sense at all. Cool? To be able to tell which one is which, as far as like which one is the correct answer, what I would do is exactly what Madison suggested. I would straight up just plug in the numbers, use your calculator, plug x in, and see if it comes out to y. How the answer explanation uses the graph. No, you don't even need to use the graphing calculator. You don't need to use the graphing calculator. You could, as an option, they say you could use the graphing calculator tool, but you don't. You don't need to. All you got to do is plug in 4 in for x and make sure that your answer is 95 for y. That's it. And then maybe choose a few more points and then plug in those x's and get out those y's. And if those are correct, we're good. And I think the big thing that chirped me out when I was looking at this initially, and I just took a look at this for the first time right now, is the 85 and 85. You know what I mean? And I'm assuming that what's happening there is, since it's an exponential decay, that's what it looks like to me, kind of one of these things, that what's going on is it's changing by so little bit over here that maybe this 85 over here was like 85.7, and then this 85 right here was 85.5. And so they rounded it, or maybe this 85 was 85.4, and this was 85.1, and then they just basically plugged it. But if we plug in 1 into answer C, it's not 190. Ah, that's a good. Really, what is 195.5 times 0.1852? Let me go grab a calculator. I'll be right back. you're right. It's 166. You're right. And I agree with Lucas. It's not exact, but it does match the best. I mean, it's not going to be the exact same data because your data is probably, remember, we're modeling the number of hours she tutored versus stuff. So, you know, when we're modeling the behavior of an actual human being, the data isn't going to be perfect. It's going to be over here and over there, depending on whether she took lunch or felt tired or whatever, that kind of stuff. So I would immediately rule these two out, and then I would say, well, which one matches the closest? Yes, I agree. That is kind of dumb. So maybe what you should do is on your graphing calculator option, and I gave you guys the graphing calculator that you guys are going to be using for this thing. I gave you a link in since the beginning of our class. You can graph it by actually plugging the numbers 195.5 times 0.852 caret parentheses x close caret. And it will give you that graph. It's an exponential decay model, like that. And then that you can compare to your data and see which one is closer. Cool. You can plug this into Desmos. I think that maybe in the graphing calculator they might even want this symbol right here. They might want you to put a times symbol in between that. But anyway, all right. Let me stop the video.